So in today's lesson, our learning target is going to be I can divide polynomials. In our last couple lessons, we went over kind of adding and subtracting polynomials, and then we went over multiplying polynomials. So in my opinion, dividing polynomials is probably the most difficult and complicated of the four operations to do with polynomials. But the good news is we follow the same method for every problem, and with practice, once you get the method down, it becomes fairly straightforward. So I just wanted to start by going over a very simple example, which would be if we're dividing a polynomial by a monomial. So recall that a polynomial is any expression with two or more terms, whereas a monomial is just one term. So let's do, for example, let's say 6a cubed minus 2a squared plus 22a, and we'll divide that by 2a. So now recall that with our properties of exponents, if we divide x to the m by x to the n, that is equal to x to the m minus n. So just a really quick and easy example of that would be x to the fifth divided by x to the third is equal to x to the 5 minus 3 power, which is equal to x squared. So when we're dividing a polynomial, which this is our polynomial, by a monomial, we're just going to apply this property of exponents. So what we can do first is we can write this as 6a to the third power minus 2a squared plus 22a divided by 2a. And now what we can do, now that we have it in this form, is we can break it up into three different terms. So we have this is equal to 6a to the third divided by 2a minus 2a to the second power divided by 2a plus 22a divided by 2a. And now we just do each of these individual divisions. So 6a to the third divided by 2a is equal to 3a squared, because anytime we have just an a, it's implied that there's a 1 here. So 3 minus 1 is equal to 2. 2a squared minus 2a is just equal to 1a. And 22a divided by a, the a's will cancel and we'll get plus 11. So this is the answer to our division. So again, if you have a polynomial divided by a monomial, we want to break it up, or first write it in this form. Then we break it up, and we just do each of these three individual monomial divisions. So now suppose we have a polynomial divided by another polynomial. So the example I wanted to start with was, say we have x squared plus x minus 12 divided by x plus 4. So now, you might want to try to apply the same method and say, okay, we're going to write x squared plus x minus 12 divided by x plus 4. The problem is, since we have two terms here, it's not going to be very easy to break it up like this. So we're going to cross this out and say we don't want to do that. Instead, we're going to use what we call polynomial long division, which is pretty much an application to the same way you would use long division to just divide real numbers. So we're going to start by making what I like to call a little house. It looks like this. and then we're going to take the higher expression the higher order polynomial, which is this one, and put it within the house. And then we're going to take the term that we are dividing by and put it outside the house. So the key to polynomial long division is that we're always going to be starting out by looking at the first term in each polynomial. So I'm going to underline those in green. And what we want to think about is, what do we have to multiply by this term in order to get this term? So essentially we're saying x multiplied by what is going to equal x squared. So the answer in this case is x times itself. X times x is equal to x squared. So once we figure that out, we're going to write an x up here. And that is the start of our answer. Now, we want to look at what we just wrote up here. And now we have to do some polynomial multiplication. So we're going to multiply this x by this x. And we're going to write that down here. So we're going to write an x squared. And then we're going to multiply this x by the second term, the 4. And we're going to write that over here. Now what I like to do is put parentheses around this. And we're going to subtract this whole thing from this. So x squared minus x squared is equal to 0. So I'm just going to write nothing there. And x minus 4x, x minus a positive 4x, is equal to negative 3x. And then I'm going to bring down the negative 12. And it's going to look like this. Okay. So now we're going to step back and see what we have here. We'll recap what we just did. So we multiplied, first we found what we needed to multiply this term by to get this term, and we wrote it up there. Once we did that, we took this term and we multiplied it by each of these and put that down here. Then we subtracted that new expression from this one, and we did that operation. The x squareds disappeared, and we have this new term down here. So now what we want to do is you want to repeat the first process. So we're going to again look at this first term, which is what we're pretty much always doing. We're always starting whatever we do based off of this first term. And we want to see, okay, what do we need to multiply this term by to get this? Whereas before it was, what do we need to multiply this term by to get this? So to get negative 3x, we have to multiply x by negative 3. So we're going to put a minus 3 up here. And then we're going to repeat what we did down here, except this time with the negative 3. So what's negative 3 times x? That's going to be negative 3x. And what is negative 3 times positive 4? That is going to be negative 3 times positive 4 is negative 12. And now again, we're going to subtract this term from that one. And we're going to get 3x minus a negative 3x is 0. And 12 minus a negative 12 is equal to 0 as well. So we get a 0 down here, which is what we refer to as our remainder. If we have a remainder of 0, that's really, really nice, because that means that our answer is simply x minus 3. And now let's check our answer now. So since division is the inverse of multiplication, what that means is that x minus 3 times x plus 4 should equal this expression. So let's try it. If we do x minus 3 times x plus 4 we'll use the FOIL method, which we went over in a previous video. We get x squared plus 4x minus 3x minus 12. And this becomes x squared plus x minus 12, which is exactly what we have here. So that makes us happy. We can celebrate with a smiley face. We can write a nice big box around our answer. So now I wanted to do one more example of dividing polynomials. So now let's say we have x squared, let's see, plus 3x plus 2 divided by x plus 1. So again, we're going to put the term with the higher degree inside our house. So we get x squared plus 3x plus 2, and we put the smaller degree one outside. So we're going to say, okay, what do we want to multiply this term by to get this? And it's the same as the last one, which is that x times x is equal to x squared. So we're going to put an x up here. And now, you multiply this by this, and this by this. So x times x is x squared, and x times 1 is 1x. And we're going to do this subtraction. X squared minus x squared is 0. 3x minus 1x is equal to 2x. Again, we didn't do anything to this 2, so we're going to bring it down. Our next step is we want to take this first term. Remember, we always base our first steps off of this first term. We want to say, okay, what do I need to multiply this by to get this? And the answer is 2. Because 2 times x is equal to 2x. And then we do 2 times 1 is equal to 2. We subtract this. And once again, we get 0. So that means that our answer is x plus 2. So now let's check our answer again using multiplication. X plus 1 times x plus 2 is equal to x squared plus 2x plus x plus 2, which is equal to x squared plus 3x plus 2, which is right there. So again, that makes us happy. So now you might be wondering, what happens if we don't get a 0 down here as our remainder? So that is a question for the next lesson, in which we'll go over more complex divisions, like we're going to start dividing fourth degree expressions and cubic expressions, and we will find out what we do when the remainder is not equal to 0. So stay tuned for that.